Okay, this is topic zero absolute value equations, first day. An absolute value, when you see these symbols look like this, that is not a parentheses. That means distance. Distance. And think about it. Distance is going to be positive or negative. So when we do a absolute value equation, we're always going to write two equations. Okay? Because distance can be 5 units to the right, 5 units to the left. So this first example, which is 5x minus 10, you will always write two equations like this. Notice there's no absolute value symbol. Okay? And then you solve each one of those just like you did in Algebra 1. So I'm going to add 10 to both sides. So I get 5x equals 55. And then I divide by 5. X equals 11. There's your first solution. This is the kind of work I should see. This one here, I'm going to add 10 as well. Does that look right to you guys? Can you guys see that in the back or no? Can you see? If you no, it's not written big enough. Okay, do you have glasses? You need to get some glasses. So x equals negative 7. Many times, kids, when they solve these, they think, okay, the first one's 11, then the other one has to be negative 11. That's not the case, is it? Okay, and then you want to check. So like, here's your original absolute value equation, and you want to check to make sure those solutions work. Okay, so I'm going to plug in 11. So 5 times 11 is 55 minus 10 ends up being the absolute value of 45. And absolute value of 45 means distance. So what's absolute value of 45 equal to? Positive 45. Do they check? Does that check? It does, doesn't it? Correct? Now let's do the other one. Take the same absolute value equation and evaluate it or check it. So I take 5 times negative 7 minus 10. Absolute value equals 45. Negative 35, correct? Minus 10 is negative 45, correct? Everybody see where I'm at? And what's the absolute value? Negative 45. It's also what? Positive 45. So it does, those two values check. It checks, doesn't it? So those two are your solutions. And in Schoology, you're going to want to write them like this, with no spaces, smallest to biggest. Does that make sense? Negative 7 is to the left of 11 on the number line. Agreed? Okay? Maybe if I wrote this would help. So, when you're writing your equations, when you have your absolute value equation, it looks like this. I just showed you first, you're going to write your two equations, correct? Here's your absolute value equation. Let's see. Notice the first equation is ax plus b equals positive c, and the second equation is ax plus b equals negative c. That's what you do first, correct? You write your two equations. Then you solve each equation separately. Why don't you move up on that desk right there and see if that helps. Okay? And then you solve each equation, agree? Just like I did, but you're always going to have two equations. Agree? If you cannot, and I'm not being facetious, I'm not being condescending, if you can't solve a linear equation, you need to get in a different class. Does that make sense? If you can't solve these two types of equations right here, you need to get in intermediate algebra 2. Okay? You should be able to solve those. Agree? Does this help writing it with that? You can see it a little better instead of the pencil. I'll write it with this. Okay, sorry about that. And then you got to check, just like I did. Agree? Plug it back in and check. Okay, turn page. Here's example 2. Here's a mistake that many kids make. Before you write your two equations, you should always get rid of everything that's on the outside of that absolute value. So what do we notice is on the outside there? A 2. So we need to get rid of that 2 first. So what is 2 doing to that whole thing? What operation? Multiplying. So you want to get rid of it by dividing both sides by 2. Those cancel, so that leaves me 2x plus 12 equals 4x. Agreed? Now what do you notice is different about this one now? You have an x on the other side too, don't you? Which is going to create some issues for you. Okay? You won't have issues when you have a constant on the other side, correct? You guys understand what a constant is on the other side. It has no variables. You really have to check these when you have a variable on the other side. So let's write our two equations. 2x plus 12 equals 4x, or 2x plus 12 equals negative 4x, correct? Does that help now with this darker pen or not? Okay, sorry about that. Okay, me, I like to always, I could bring my 4x over here and my 12 over there. Me, I like my x to stay positive, that's just me. Those cancel, so I have 12 equals 2x, and I divide by 2. I get x equals 6. Okay? Let's check it. I'll solve this other one, then we'll do it here. Okay, so on this one here, I'm going to add 4x and get it over here. I like to keep my variable. You don't have to do it that way, but me, I like that variable to be positive, so I don't have to worry about dividing by a negative. Does that make sense? That's just me. You don't have to, though. Does that look good to you guys? Everybody see what I'm doing? Then I divide by 6. I get x equals negative 2. Agree? Now what do you have to do? You have to check it, because when you have that variable on the right side, we're going to see if they both work. Does that make sense? Because sometimes they don't. Alright, so here's your original equation. Absolute value of 2x plus 12 equals 4x. And I'm going to check with x equals 6 and x equals negative 2. Okay? I'm going to check it. Here we go. I'm going to plug it in, which means I'm going to evaluate. So the absolute value of 2 times 6 plus 12 equals 4 times 6. Everybody see what I'm doing? Right here. I plugged that in for x, didn't I? Correct? Agreed? Okay, 2 times 6 is 12. 12 plus 12 is what? 24. 4 times 6 is 24. What's the absolute value of 24? 24. So does that one work? Yes, it does. It is a solution, isn't it? So this one is a solution. Now let's check the other one. absolute value of 2 times negative 2 plus 12 equals 4 times negative 2. Everybody see where I'm at? See what I'm doing? I'm plugging this in right here for x, aren't I? Agree? Okay. 2 times 2 is negative 2, or excuse me, negative 4, plus 12 would be 8, correct? 4 times negative 2 is what? Negative 8. What's the absolute value of 8? 8. Does 8 equal negative 8? No, that is a false statement, isn't it? So x equals negative 2 is not a solution. So we call it an extraneous root. So there was only one solution there, okay? So you have to check these. And when you take the absolute value of a constant, it's always going to come out positive, isn't it? Because absolute value means distance from 0. Distance can't be negative. Questions? Am I going too fast? Because I can do this in my head. Just tell me to slow down. Are we okay so far? Okay. Okay, example 3, is that right? Okay. I'm going to do it right here for you. We have x, absolute value, or the distance of x plus 24 plus 3x equals negative 4x. Is that what you have on your paper? Correct? So what do we have to do first? We have to isolate the absolute value. Now, I've done this I'm as old as dirt, kids. I'm just telling you, the mistake that kids make is they forget to isolate that thing first. That's what you have to do first before you write your two equations. Or you'll get the wrong answer. I'm just telling you. Okay? So you might put a little note out to the side. Isolate the absolute value first. And you see me abbreviate a lot of times. ABS means absolute value, okay, or absolute. All right? So we're going to have to do this first. Agreed? So that gives me the distance from 0 of x plus 24 equals negative 7x. Are we okay so far? Is it isolated? Okay, now we can write our two equations. This one's going to be a little different, isn't it? X plus 24 equals 7x, and x plus 24 equals negative 7x. You guys see what I've done? Okay, I'm going to subtract x. Cancel, cancel. Divide by 6. X equals 4. So we think that's a solution, don't we? We'll check it here in a second. Subtract x. I don't like to do that, but that's okay. We can do that. Divide by negative 8. So x is equal to negative 3. Does that look right to you guys? Now, many times you see this x equals negative 3, and you're saying to yourself, well, I'm going to throw that out as extraneous because an absolute value can't be negative, right? Let's check it, see what happens. Okay? You guys hear what I'm saying? So here's let's check the first one. We have the absolute value, and I'm always going to check with the original. I'm always going to check with this one after I isolated it. Does that make sense? Agreed? So I'm going to plug in 4. So I have 4 plus 24 absolute value equals negative 7 times 4. So here's what I plugged in, right here. Agreed? This gives me absolute value of 28. This gives me negative 28. Ooh, looky there. Was 4 a solution? No, it was not. That's why you got to be real careful. So that's a false statement, isn't it? So that one there you can throw out. And what do we call that root? Extraneous. An extraneous root. Not a solution. Now let's do this one here. Negative 3. So that gives me negative 3 plus 24. Absolute value of that quantity equals negative 7 times negative 3, correct? Right here is where we plugged in. Agreed? Everybody see where I'm at? This absolute value of 21 equals 21. So that one checks, doesn't it? See how tricky that one was? That was a little tricky, wasn't it? So your only solution this time was what? Negative 3. That was your only solution. Is that making sense? Questions? Okay, let's see here. Example 4. I write so big, I think I'm going to get some. Does it look better when I do it on paper? So I have to I write big, and just set up in the classroom makes it better to do it that way. So I'll just do it on this paper. Okay, so we have, this is example 4, which is the opposite of the absolute value of 3 minus 7x equals negative 2x minus 1. Okay? So, again, we have to get rid of everything on the outside of that absolute value, don't we? Correct? So, how are we going to get rid of it? We're going to divide both sides by negative 1, aren't we? Agreed? Now you got to be careful when you have a quantity on the other side, because you got to divide everything by negative 1. Correct? So then that gives me this. The absolute value of 3 minus 7x equals positive 2x plus 1. Agreed? Agreed? Everybody see where I'm at? Now we're ready. Now this is a little tricky here, so you better watch. I'll give you time to write it. Your first equation is easy, isn't it? You just copy it down with absolute values. Agreed? That's easy. Okay? The second one is going to be a little more difficult, because, and here's where kids make mistakes. You have to negate everything, which I mean by negate means you're going to multiply every one of those terms by negative 1. So here's your second equation. So it's like distributing this thing here by negative 1. Okay? A lot of times kids will just do this negative 2x. You have to do both of them if you change the signs of both of them. When you hear me say negate, that means change the sign. Okay? Alright, so I'm going to add 7x to both sides here. Cancel, cancel. Subtract 1. Divide by 9. So x equals 2 divided by 9. If the fraction is a repeating decimal and you need to leave the answer as a fraction. The only time you can write it as a decimal is when it's terminating, correct? So you have to leave it as a fraction. You can put it as a decimal if it's a terminating decimal, like 1/2, you can write 1/2 or 0.5, can't you? 2/9, if you take 2 divided by 9 on your calculator, you're going to get 0.111111 and it keeps going. So you have to leave it as a fraction. Does everybody understand when you leave it as a fraction and when you can write it as a fraction or a decimal? If you leave the answer as a fraction every time, you'll never have any problems. Is this making sense or not? Okay. Let's do the next one. I'm going to add 7x. So I get 3 equals 5x minus 1. Add 1. I get 4 equals 5x. Divide by 5. I get x equals 4/5. Now, you can write that one there as a decimal, can't you? Because what's 4/5 equal to? 0.8. Agreed? This one here, you can't. You got to leave it as a fraction. I just leave them as fractions and not worry. Now, let's check them. So here's our I'm going to have 3 minus 7 times 2/9 absolute value equals 2 times 2/9 plus 1. I'm checking it there, okay? Pull your calculator out. I'll show you a quick way to check it. If yours is not working, let me know. I'll get it. So how do you turn it on? Okay? If yours is not working, raise your hand and bring it up here and I'll get you a different one. Some of those don't have batteries in them yet. You just have to watch and then later do it, okay? Because if they're not working, let me know and I'll put batteries in them, okay? But you can go back and watch this video. Okay, here's what we're going to do. You see where it says math? Hit math on your graphing calculator. Okay? And then right arrow over to number. And you see number 1, ABS. Hit number 1. And then now let's put in 3 minus 7 parentheses 2 divided by 9 close parentheses and then hit equals and it's 1.44444. It's a repeating decimal, isn't it? Agreed? So this one here is 1.44 repeats. Okay? Over here, hit 2. Let's check, get the other side. 2 parentheses, 2 divided by 9, close parentheses, plus 1. Okay? Everybody see what I'm doing there? Whenever you have, everybody look up here real quick. Whenever you have a division symbol, you have to put parentheses around that thing. Does that make sense? You have to. Because it creates the orders of operation that you want to do. And I hit enter. Do I get the same thing? Yes. So that one checks. It checks. So that one there is a solution. Now let's do the other one. So we have 3 minus 7x absolute value equals 2x plus 1. Okay? I'll go real slow, put them in the calculator. So we're going to plug in what? 4/5? Whoops, equal sign. Absolute value equals 2 times 4 divided by 5 plus 1. Agreed? Everybody see what I'm doing? I'll go real slow. So where do I get that absolute value? Hit, I'm going to clear this all out. Hit math, go to math, then right arrow over to number, and then hit number 1. And then type in 3 minus 7 parentheses 4 divided by 5 close parentheses and hit equals. I get 2.6. This one over here, take 2 parentheses 4 divided by 5 close parentheses plus 1, and what do I get? 2.6. So they were both solutions this time, weren't they? questions and I'll stop. What did you learn about your calculator? If you have a division symbol, you have to put what about it? You have to put parentheses every time. Yes, sir. What do you got, bud? Negative 2/9, you mean, or what? You mean 2.6 here? You plug in the original when we plug it into this one here, correct? Before you write your two equations. Does that make sense? Good question. Plug it into the one that has the absolute value. That's a really good. Don't plug it into these two equations that you rewrote here. Does that make sense? Good question. Plug it into this, not into each one of those. Does that make sense? That's a really good question. Thank you. Does that make sense or no? Does everybody see how you use your graphing calculator? And I'm going to do this every time so you'll learn how to navigate better. Okay? All right. Turn the page, example 5. Is that it? Okay, so let me stop this. And then now you can start on your homework.